All right. Today I'm going to give you some notes on factoring trinomials. Which is section 13.3. So in 13.1 and 13.2, you looked at factoring out the greatest common factor and factoring by grouping. And you'll notice if you have looked at 13.3, there is more than one method to use to factor these. The method I'm going to show you, though, will work. So you only need to learn one method, regardless of what the directions say, for instance, in my math lab. So let's get started. Let me get to my correct page here. All right, so let's take y squared minus 10y plus 9. So the first step is to take what we call the leading coefficient here, and we're going to multiply that by the constant. So we're going to say 1 times 9, and that equals 9. And then we're going to list all the factor pairs of 9. In other words, all the pairs of numbers that multiply to give you 9. So that would be 1 times 9 and 3 times 3. Now, we want to pick the pair that also combines to give you this middle number, negative 10. Well, 9 and 1 can give us 10. To give us negative 10, they would both need to be negative. So what we're going to do for this method is rewrite this middle term using this combination. So I'll say negative 1y minus 9y. So I've replaced this middle term with its equivalent, so I haven't really changed anything, just changed how it looks. So what we're going to do now is separate this into two pairs. So essentially we're going to factor by grouping, which y'all just learned. So I'm going to factor a y out of this first pair, and that leaves y minus 1. Bring down the sign, and then what goes into both of these would be 9, and if I factor that out, you just have to be careful because negative 9 times negative 1 gives you a positive 9, so watch your signs. And then the last step is to factor out the GCF. I have something minus something. Both of those somethings had the GCF y minus 1. And if I pull that out, that leaves y minus 9. So this is my answer. And you can FOIL it out to be sure that it works. So again, the steps there are to rewrite that middle term using the steps that we talked about here, and then factor by grouping. All right, so let's go on and look at another example. Let's take x squared minus 3x minus 18. So again, you start by taking this first coefficient, which is an understood 1, and we're going to multiply 1 times 18, so that equals 18, and then list all the factor pairs. So that's 1 and 18, 2 and 9, 3 and 6. I think that's it. So now we want to pick the pair that combines to give us a negative 3. So that means either by adding or subtracting. In this case, 3 and 6 can give you 3. If we want it to be a negative 3, it has to be a negative 6 and a positive 3, because 3 minus 6 is negative 3. So I'm going to rewrite this middle term as positive 3x minus 6x. Now someone usually asks at this point, well, what if my list is reversed? What if I have 6 times 3? It will still work. You will get the same answer in the end, regardless of what order you have these in. So now we're going to factor by grouping. Here I have x, and that leaves x plus 3. Bring down the sign. So that's just an arrow reminding me to bring that sign down. And then the GCF here is 6, and that leaves x. plus 3, because negative 6 times positive 3 is negative 18. So now we're ready to factor out the GCF from these two terms, which gives us x plus 3, and that leaves x minus 6. So that's our answer. Whoops. And then we'll, again, you can always FOIL it to check. So both of those had in common that they both had that leading coefficient of 1, but that will not always be the case. Let's take this example, 3x squared plus 11x plus 6. So steps are the same. Take the leading coefficient 3 times the constant, which is 6, and that gives us 18. List the factor pairs, so we have 1 and 18, 2 and 9, 3 and 6. And we need the combination that gives us 11, so that's going to be 2 and 9. 2 and 9 would add to give you 11, so they both need to be positive. Replace this middle term with positive 2x plus 9x. So again, we're not changing our expression at all. We're just rewriting it. So now I'm going to separate into pairs, factor each pair. So here I can factor out an x, and that leaves 3x plus 2. Bring down the sign, and here I can factor out a 3, and that leaves 3x plus 2. Now the GCF of this term and this term is 3x plus 2, and that leaves x plus 3. And that's our answer. All right, 8x squared minus 22x plus 5. So you might want to pause this and try this one on your own, and I will just jump right in. So I have 8 times 5 is 40. Factor pairs, 1 and 40, 2 and 20, 4 and 10, 5 and 8. Hopefully I got them all. Let's see. We need to get 22. 2 and 20 give us 22. They add, so they both need to be negative. So that's negative 2x minus 20x. One pattern you will see is if you need these two numbers to subtract, then the signs will be different. If you need them to add, then they will be the same, either both positive or both negative. So now we go ahead and factor by grouping. So this would need to have a 2x, and that leaves 4x minus 1. Bring down the sign, and we can factor a 5 here. Factor out a 5, and that leaves 4x. Negative 5 times 4 is negative 20. And then negative 5 times negative 1 will give you a positive 5. All right, GCF, 4x minus 1, 2x minus 5, and that's our answer. All right. (24x to the 4th plus 40 x to the 3rd plus 6x squared. Okay, so all of these problems will say factor completely. Factor completely. So what we need to do is look for what they all have in common. So 6 goes into 24 and 6, but 6 does not go into 40. So the GCF for the numbers will just be 2. Now for the variables, remember the GCF is always the smallest exponent, so this would be x squared. So now we're going to factor this out. This is the first type of factoring we learned, just factoring out the GCF. This would be x squared because x squared times x squared is x to the fourth. And then we have plus 20, 2 times 20 is 40, and then x to the first, and then plus 3. So now what we're going to do is just leave this alone for now. At the end of the problem, we'll bring that back in, but we're going to look at just this trinomial and factor it the way we have been doing. So we have 12 times 3, which is 36. Factor pairs, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so does one of those pairs add or subtract to 20? Yes. To get a positive 20, we're adding, so the signs are the same, and they're both positive. Rewrite the middle term. Again, just ignore the 2x squared for now. We'll pull that down at the end. Separate into pairs. Factor each pair. So the GCF for these would be 2x, and that leaves 6x plus 1. Pull down the plus. Factor a 3 out, and that leaves 6x. 3 times 6x is 18x. 3 times 1 is 3. Now the GCF from both of these is always what's in parentheses, and that leaves 2x plus 3. By the way, if you cannot get the same thing in parentheses, either it means you made a mistake or it can't be factored. So we have that to think about now. And I started wrapping this up too soon because I was talking at the same time. I'm not done yet because I need to remember to bring down this factor. Now I'm finished. So we end up with 3 factors this time. All right, so hopefully that is helpful to you. Just shoot me an email if you have any other requests for demonstrations. Sorry about that squeaking. And I'll see you later. Have a great day.